Good afternoon. Not for me, it's morning, but good afternoon for most people. It's really great to be here, and we're really excited to talk to you today about Purple Graph, which is the secure innovation boundary that we've put in place over our core systems at Telstra Purple. So my name's Rob Moore. I'm the Delivery Innovation Lead for Telstra Purple, and my role in this story is the orchestrator. I came up with the original idea of doing this, and I've been playing a little bit of a hand in the background to help make it successful.
My name's Kieran Jacobsen. I'm the Head of Information Technology at Telstra Purple. My role in this story was I'm one of the leaders or the leader of the DevSecOps team who are responsible for a lot of our internal systems and infrastructure.
My name's Sam Curry. I'm a lead consultant at Telstra Purple. My role in this story was developing the initial prototype and then some ongoing development and support of this GraphQL API.
So today we are going to be telling you a story. We're going to take you on a journey, the journey that we've been on over the last few months. We're going to start by talking to you about why we did this. What's the business context? What were the problems that we were seeing? We're then going to talk through how we came up with the idea and how we then pitched it. And from there, the prototyping phase that we went through to sell this vision and make the decision to actually go ahead with it. We'll take you through how we then productionized that prototype and what we did to then launch Purple Graph and make it successful. We'll then take you through some learnings that we've had over the last few months in operating it. So, Kieran, can you take us back to the start? What were the business problems we were seeing? Why did we do this?
So we were starting to see some business problems with the way that our different systems, especially our core systems and some of our more edge systems, interacted. And Telstra Purple is a large organization of around 2,000 people. Our parent company is even larger. We don't have a sort of central team that's responsible for managing and maintaining every single system. That sort of work is spread out across different teams, across different parts of the organization. And if you want to start getting access to a system or an application, especially at the API, you need to sort of work together with all of these different teams, work out how you engage with them, their security requirements, and what they might require in terms of approvals to get at, to actually be able to allow to start doing some of this work. And this represented sort of our first roadblock to innovation. If you wanted to create that solution to a business problem, to actually get in and write code, you first needed to spend some time navigating these different teams. Not all of our systems come from a single vendor. We've got different vendors, and each of these vendors and systems have different approaches to how they handle authentication, authorization, and telemetry. We've been lucky that we have single sign-on to a lot of the user access sort of user interfaces, and that's all happening through Azure AD SSO. But when it comes to API access, authentication is a really different story. Some of the APIs are using user or global level API tokens. We've got every version of OAuth in use in the environment. And some of the applications, because they don't supply API access, we're actually using direct SQL queries to their databases. Combining all of this pain with the fact that there's the reuse of shared credentials and tokens, we've got quite a nightmare when it comes to security and access. If you're trying to bring in data from multiple different systems at once, this is a really complicated landscape to try and get your head around. So let's say that you've got approval to use the API, you've managed to authenticate with that API, you've got some data, but what does all of that data mean? How does a timesheet entry relate to a leave request in a HR system? And even with the best documentation, much of that understanding, the ability to really get business value out of that data resided with a few subject matter experts. They had become unwilling gatekeepers to the value of our business data. They were a bottleneck to innovation. They caused a lot of problems. And as one of those gatekeepers, I often felt like we were sort of a group of ancient mystic scholars that could translate some sort of mystic tomes of knowledge. And that's not what we wanted in our business. What we really needed to do is make our business data more understandable to everybody in the organization, not just these ancient scholars. And the final issue that we were starting to face was that our systems were becoming more and more tightly coupled together. Most of the access, as I said, was happening through native APIs, but we had some situations where, due to performance issues or running into API call limits or some of the different teams' business rules, we had to come up with some more creative solutions, let's say. What we were doing, or what we have been doing, is having jobs that run on a regular basis. They use the API to pull down the data from those systems, and then they push it across to Azure SQL database instances. This had the drawback, though, and you probably all can see it, is that a lot of systems and applications became really tightly coupled to the databases, particularly their schema. We had some cases where we had some performance issues, but we couldn't really get in and fix those performance issues without breaking some of those critical downstream applications. We had some real problems, and what we needed was a superhero to come to our rescue.
And I guess that's where my part in this story begins. How did I take this idea of creating Purple Graph to solve some of these problems that Kieran is talking us through, and then pitch it? But before we talk through that, we need to rewind about 10 months before I started pitching it. And I want you to meet Ben. He's one of our awesome recent graduates. And I distinctly remember sitting with him in our Perth office and talking to him about some innovation that he was trying to do at the time. He was trying to take data from some of our core systems and visualize it in a different way so that we could be more efficient in the way that we work. And I remember sitting there and hearing him describe some of the pain that Kieran just took us through. And then he just dropped this bomb on me and gave me this amazing light bulb moment. He said, how amazing would it be if we had a GraphQL API over all of our core data that we could just empower people with, and they would just have access to the data in a describable way. And this really stuck with me. And so as we started seeing the problems that Kieran just took us through, this idea really came to the forefront for me and started evolving. And from there, I started pitching it. And there are a number of techniques that I used whilst pitching it. The key one was I was really consistent and persistent with how I talked about it, and also topical. I remember having a discussion with Kieran directly after we found some of those database coupling issues he just talked about. And I was, showing how this idea that I had could help to solve that. As well as that, I made sure to focus on the why. We didn't just want to put in tech for the sake of tech. We wanted to identify the problems in our business and actually align a solution to that. And from the solution perspective, I didn't want to talk about the specific technology. I wanted to talk about the approach that we could take. So in this case, it was talking about a model-based solution or a model-first solution, where we start modeling out our business and exposing that model and empowering people with that model. But to give confidence that it was possible to do it, I did start bringing in a certain technology, and that was GraphQL, because it's something that is, steadily gaining more and more prominence. And there's lots of great stories of really big companies using it to successfully solve problems. Now, one example I remember, I gave a video to Kieran about GraphQL. Do you remember that, Kieran?
Yeah, I do. And that was a video that was really oriented around talking IT leaders through some of the problems that GraphQL can solve. And I remember sitting there and watching that video and just sort of ticking off a lot of our the situations we were in, and even some of the advantages that GraphQL brought to us. And I think my statement when we caught up next time was just, I want this now. When can we get this into production?
Absolutely. And this is a really good example of the last one, which is that I made sure that when I was having these discussions, I would tailor it to my audience. So when talking to Kieran, I found a video about how GraphQL can be used to help with IT operations. And I'd have a lot of discussions with him about security, which is something I know he's really passionate about. Now, as well as using certain techniques to pitch the idea, I was also really careful about the audiences that I was pitching it to. And there's three main groups. The first were the people that had a direct influence in the decision of whether or not we would adopt something like this. namely Kieran and the enterprise architect that we had at the time. But I also made sure that I was pitching it to our exec team so that we would have the necessary buy-in if we, needed to allocate, focus or money or anything like that towards it. And the third one's a little bit tongue-in-cheek, but I basically talked to anyone that would listen. And there was two things that this gave me. The first was it gave me lots of broad perspectives so that I could constantly hone the pitch and the vision and the idea. But secondly, it gave me a chance to continually practice talking about it. And I became really, really good at very clearly and succinctly articulating the vision that I had. Now, one of the other things that I did, and I'm a big fan of using internal marketing to get concepts across and successful within companies, is I created this slogan here that you've seen because it's in the talk title, Secure Innovation Boundary, because I found that it was a really nice way of very succinctly articulating the key points of what we were trying to achieve. Now, as the discussions got a lot more serious, I started working with our enterprise architect to design how this could look in our company. Now, we had an existing set of core systems, things that you would imagine, like HR information system, customer relationship management, professional services, automation, finance, etc. And as Kieran talked about before, we had existing automation that would take data from those core systems, put it into reporting databases, and then surface it into Power BI so that everyone in the company would have visibility. And we also had a series of custom apps that were built by all kinds of people in our company to help make us more efficient. Now, what we started designing was a series of layers that could exist in our architecture. The first one would be owned by Kieran's team, and it would involve all of the interactions to those core systems. The next one would be open for contribution for our entire company, but it would be reviewed by Kieran's team. So there's a minimum level of quality. And then we were really keen to have a third one, which is more of an unmanaged area that we could empower on-the-ground innovation and experimentation through a combination of ad hoc and programmatic access to our data. The idea being here that people could create things that had a limited impact. So they weren't things that would affect the whole company. They would affect maybe a single team. And we didn't want to get in the way of them doing that because we wanted to foster a culture of innovation. And then what we put in place in this design was that we would have our secure innovation boundary in the middle here to help make this real. And we could then pull data from whichever data sources made sense and surface that to all of the other areas that needed information. So at this point in time, we're getting more and more traction. And the awesome thing is there's a moment in time where the stars just aligned. I had really good buy-in from the exec team. Kieran and our enterprise architect were, really getting excited about this idea. And then Sam, who had experience in implementing something similar for one of our financial services clients, where we put a GraphQL layer over a core banking system to help empower their experienced teams and solve similar problems to what we were experiencing. He landed on the bench, and so he had a level of availability. And so I did what any good leader does. I put all of the right people in the room and let the magic happen. So, Sam, can you tell us what happened from your perspective at this point?
Yeah, so Rob called me up and he pitched his idea and said, how'd you like to work on this? I was sold on the idea and thought it could work. So I said, absolutely. As Rob mentioned, I'd recently finished working on a GraphQL API for a corporate client. So from this, I had lots of learnings across technical and operational aspects of this kind of project. I asked my squad lead for 4 weeks to work on a prototype, and I was given the green light. Now, 4 weeks isn't a huge amount of time, but I'd been helping build some intellectual property for Telstra Purple on GraphQL, so we had a lot of stuff ready to roll, and I felt pretty confident. I've been thinking a lot about team topologies, cross-team engagement, and the operational side of software delivery. So I really wanted to help create an API that could be developed, consumed, and operated successfully, not just deliver a working prototype. I'll now discuss some of the technical and strategic considerations that went into the prototype. I won't go into much technical detail, but we'll share a page of links to most of the libraries we used to put it together. First things first, the schema. We needed to create an API which reflected our organisational model, not the systems we use to run it. Those systems often don't reflect our org model well, plus they change and sometimes get replaced. One of the nice things about GraphQL is that the schema definition language, SDL, is simple and concise. So it's easy for technical and non-technical people to understand. So it can be used as the medium for modelling the organisation and to support modelling discussions. You can generate a schema from code, but for this kind of API, I'd recommend a schema first, model first type approach. Consumer experience is an important consideration, especially for this kind of API. One of my big learnings from past experience is that when creating a fancy new GraphQL API, it doesn't matter how good it is if no one uses it. First adopters are usually the most cautious, understandably, but I've made the mistake before of assuming it'll get used just because we created it. I knew I needed to present this prototype well and to make it accessible and attractive to consumers. Otherwise, I might end up building an expensive white elephant. A GraphQL API is generally not built for one specific consumer or a finite list of use cases. So to be successful, it needs to be discoverable with documentation and user interfaces to support exploring it and trying it out. GraphQL Playground is the IDE that comes bundled with Apollo server. It's a great user interface for writing and running queries and exploring the schema. Voyager is another useful UI. It renders your schema visually as an entity relationship diagram, allowing you to browse the schema and navigate through relationships without worrying about writing and executing queries. There'll be a short demo of these UIs later in this presentation. Last but not least, good schema documentation is essential. The SDL supports multi-line comments with Markdown. Having good quality documentation enables consumers to help themselves without needing to find people to answer their questions. The overall goal of these tools is to support consumers in a really hands-off approach, where anyone in the organisation can find what they want without needing to ask other people, and there's no barriers to entry. The next big consideration for me was how I can create operational confidence. GraphQL is still a bit new and out there compared with REST. So we're talking 5 versus 20 years. And equally, a lot of companies are much more familiar with building running APIs using .NET or Java over Node.js. I wanted to convince everyone that we could write and run Purple Graph in TypeScript using Apollo server running on Node.js. However, it wouldn't be me that's responsible for running this API. We have a dedicated DevSecOps team for that, and I'd need to convince them. I wanted to be able to demonstrate that we can confidently and reliably land changes. To me, this means having a solid CD pipeline, so when you create a PR, if it builds and passes all the automated checks, you should have the confidence you can merge it and walk away, and then the automation will take care of the rest, including things like blue-green deploys and automated rollbacks in case of failure. We need confidence that our hosting is reliable, performant, and scalable. So in this case, I thought app service was a better hosting choice than functions, since it gives us auto-scaling, but also gives us that always-on performance and allows the app to use things like connection pooling for database access, caching connections to downstream data sources, etc. Staging slots on app service are also an easy way to implement blue-green deploys and run an integration test before swapping slots. It also gives you a rollback option for free. We would need confidence that the system is observable. So to run an API that exposes our company data, we must be able to see exactly who is accessing what data, right down to the field level. We'd want to monitor and visualize the performance constraints of our data sources. The App Insights client for Node.js supports collecting and correlating a variety of metrics automatically, and it's also easy enough to add custom dependency tracking, which we did. We'll show you some of the data and visualizations in App Insights later. We expect to be building an API mostly over eventually consistent read-only data sources. So in this kind of scenario, caching can give you a big performance boost. Apollo Server lets you define cache control directives in the schema against types, operations, and even fields. This makes caching behavior super simple to understand and configure. Azure Cache for Redis is one of several cache providers that just plug straight into Apollo Server, and it supports both server-side response caching and client caching. so I was confident we could handle load and create a performant API. Overall, I thought we'd be able to convince our DevSecOps team to run this thing even if it was a bit different to what they were used to. We were proposing to create an internet-facing API to expose our company data. Clearly, this isn't a trivial matter. We'd need to demonstrate that we can effectively secure our API and apply access control across that data. We'd also need to support a variety of system integrations. Telstra Purple's identity platform is Azure Active Directory. This already handles app registrations, identity data and access control, people data, and the OAuth2 and OpenID Connect protocols. Passport's a modular authentication middleware for Node.js with lots of plugins which include auth strategies for all sorts of platforms and protocols. There's an Azure AD plugin by Microsoft which has a Bearer strategy for back-end Bearer token validation and an OpenID Connect strategy for server-side hosted front ends, which in our case are the Playground and Voyager UIs. Authentication is pretty much a once-off setup, but authorization and access control is where things get more interesting because that grows organically over time as you expose new data and support different integrations. GraphQL Shield is a library that supports composing authorization rules and applying them across your GraphQL schema against operations types and fields. This is achieved by layering authorization as a GraphQL middleware above the data resolvers. This approach gives you a nice declarative implementation that's easy to understand and to change without digging around in data access code. During the prototype stage, we didn't have much in this layer, but it did develop really well later. In order to attract and support developers, we'd need to provide a first-rate developer experience. I need to convince C# developers that the TypeScript Node.js experience could stack up. First up, having a great README with a concise getting started section so people can get running as fast as possible, along with comprehensive documentation to support development of new features and a table of contents so you can find things. Using TypeScript nowadays is really a no-brainer for the best IDE experience. It seems like most libraries we use now are either written in TypeScript or come with types. It's pretty rare to find one without. For TypeScript and the F5 experience, the TS Node Dev package makes it seamless to just launch straight into TypeScript with the debugger attached, watching code, schema, and config files to automatically restart on change. For logging, we use a great library called Winston.js, which supports structured logging and multiple transports. So we use the App Insights transport straight out of the box. We apply coloured YAML formatting for console output to make it nice and readable. Using Prettier and auto format on save is another no-brainer for me. I can't imagine going back to manually formatting code. For writing in GraphQL schema and queries, the VS Code GraphQL plugin gives you query and schema IntelliSense and allows you to run queries from inside VS Code. And finally, testing shouldn't be a dysfunctional chore. I wanted to provide a first-rate testing experience that supports contributors. We want the confidence that comes with good test coverage and automated tests without making it slow and painful. Since a lot of our tests are just checking data out, we use approval tests where we can. We generate approval tests from a simple convention where we place a query file in a folder and a data file containing a set of inputs for the query. This makes things as easy as possible for developers to add test coverage. We can also use those same query files to run load tests. The artillery package will run a load test from a CSV-based dataset. We can easily run load tests via a separate YAML pipeline that allows us to define the load test parameters. Finally, using VS Code Test Explorer provides an IDE integrated test runner, so we can run and debug individual tests or groups of tests. So after 4 busy weeks, we had a working prototype. I'll hand over to Rob now to run a short demo.
Thanks, Sam. I think it's fair to say that one of the things that made the prototype really successful was, frankly, just how amazing and comprehensive it was. Kieran, I mean, you were one of the recipients of this, you and your team. How would you describe, seeing that demonstration?
It was one of the most polished prototypes that we'd ever seen. The quality was really high, and that's what really helped myself and my team, buy into this solution, was that the effort that Sam had gone to build such a high quality prototype.
Absolutely. And so I was keen to just do a quick demo of not only some of the things that Sam was showing after that prototype, but just also to give you a feel for what Purple Graph actually is. So let's flip over to here. This is the Voyager user interface that Sam mentioned. So as he said, it's basically like an ER diagram. It's got all of the different entities and the relationships between them. And this gets auto-generated. So it's a really nice UI to allow someone that hasn't seen the model before really just explore it and understand the data that's in there that they could potentially use. And we can do really cool things like I can, dig into one particular entity here. You can see the booking entity. We're a consulting company, so bookings are a pretty core sort of data entity for us. And we can see those relationships. We can see the descriptions of the fields and the entities and all of that sort of thing. The second UI that Sam mentioned was this one here, which is GraphQL Playground. And so this allows us to have a query like this, which has syntax coloring and IntelliSense. We can hit play. We can actually see that data come through from the real systems. And we've got this really cool feature here, which shows us a tracing view that pulls sort of telemetry information that comes into the request. Now, there's a bit of a weird UI bug here where sometimes it kind of displays very horizontal like that. But putting that aside, you can see here, there was a call for the people search, which is a database call. And then after that came back in parallel, there was a call to get the manager and a separate call to get the position history. And so you can kind of see here on a per field level, how long did it take and what was running in parallel? It just gives you really nice visibility into the impact of the query that you've just run. Now, one of the great things about this UI, especially for someone that's not that familiar with the model, is that you get this wonderful IntelliSense. And this is really made possible by GraphQL because it's got that strongly typed introspectable schema. And so you can see here, I've done a control space. I can see all of the different fields that I could look at from the people or person entity. And so one of the things we've mapped in is profile photo. And you can see here, as I'm typing, it's just suggesting things for me. So it's so easy to very, very quickly write a query and get some different information. So if I execute that, we can scroll down here. We can see I've got my base 64 encoded. This is the large size image, which as it turns out is 240 by 240 pixels. And if I actually copy that base 64 encoded string, we pop it in here, you can see when it loads, there we go. That's my image. And that's actually, we've retrieved that from the Office 365 Microsoft Graph. That's my profile photo in our Office 365. And if I flip back here, what we've done here, what we've demonstrated is this information here is from our HR system. This information here is from a completely different system, MS Graph, but we can execute one query and we've joined it all together. And this is part of what makes GraphQL so powerful. You don't need to worry about all the different systems. You just talk about the data that you want in a model that's easy to understand and it gives it back to you. It's brilliant. So next thing I wanted to show you was this. Sam talked about how observability and telemetry was really important. Now for us, Purple Graph is going to be a bit of an aggregator. It's going to talk to a lot of different systems and aggregate data from those systems. So having visibility into all of those sort of third-party calls is essential, especially for Kieran's team who need to operate this and understand what's going on. Now, one of the cool things in App Insights is this view here, which is the application map. And this shows you all of the different calls to the different endpoints, be it databases or REST or blob storage or whatever it might be. It shows you like the number of calls over a time period, in this case, the last 24 hours. It shows you the average response time. It shows you the percentage rate of errors. And then you can actually drill into a lot of detail. So if I click on this one here, we can see that it shows you the different calls and how slow they were. So we could like dig into this booking by days and say, well, 5.3 seconds, that's quite a lot. Let's find out why that is. The other thing that we get with the telemetry is the ability to really kind of search and then explore in detail calls that we might make. So in this case, I'm just searching for a particular on behalf of kind of trace log here, because I want to show you that query I just ran with the profile photo, because it's quite impressive. You can actually see a timeline of everything that happened when that call landed. So we can see here the people search, the people by ID to get the manager, the position histories, and then we've also got this post request to the Microsoft Graph. And you can see like these ones were in parallel, and then this one came after, and all of this sort of thing. And we've also got our telemetry, which we're using structured logging for. And there's lots of really cool information in here. Like, for instance, you can see the SQL query that was issued to the database. We can see things like the call that was sent to the Microsoft Graph and how long that took, and the result code, and all of these other things that are in here. It's really, really powerful. One of the other things that Sam mentioned was around the developer experience and the fact that there was a really incredible README. And Kieran, I think it's fair to say that the README was one of the things that really sold you and your team. Is that a fair statement?
That is. It's one of the most detailed but also just well-structured READMEs that we've seen in a long while in some of these projects.
Absolutely. And just to give everyone a bit of an idea of that, here's the table of contents. So we've got like getting started, we've got the environments and the cloud resources, we've got a whole heap of stuff about testing, configuration, dependency injection, authentication, authorization, how to build new parts in the schema, how to do resolvers and data access, including some of the different patterns we use like database calls and REST, how we do caching, how the build and deployment pipeline works, logging and monitoring, health checks, and the roadmap of upcoming features. So as you can see, it's really, really comprehensive. Now, the last thing I wanted to show you was just a small slice of the sort of developer experience. So I've got VS Code up and running here. I've done a clean clone. I've done an npm install. I've opened up VS Code and I've hit F5. That's it. And I've set a breakpoint right here, and this is in the story resolver. And so if we go here to my sort of localhost GraphQL and I execute this query and I flip back to VS Code, you can see that that breakpoint's been hit. So just off the bat, we get breakpoint debugging. I can hover over here and see that ID that I've passed through. I can let that query go through, and then you'll see the actual result come in. Now, this is really powerful. We get this sort of breakpoint debugging, but not only that, inside of the terminal, we actually get this awesome experience that shows all of that telemetry coming through. So we get really good visibility. And for instance, we can see the query that was executed here. We can see the HTTP request that was sent to, in this case, a REST backend. And then we can see the final trace for the entire request, including the duration of how long it took. So that experience, that developer experience from day dot is awesome. It's really nice. Now, we've just talked you through the prototype that was built. Of course, at that point in time, Kieran, you kind of had some decisions to make, didn't you? Yes,
I did. And so let's start to talk through some of the sort of the decisions and thinking that we had to make. So one of my roles, or sort of things that I need to do as head of IT, is advocate for technology change in our organization. And that's not just the wider organization, but also within my team, because they're the ones that have to be comfortable supporting all of our core systems and apps. For this project to be successful, my team needed to be really confident in GraphQL. And thankfully, as I've said, and as we've been talking about, Sam's prototype made it really easy to pitch that to my team. They still talk about the level and the quality of the prototype, in particular the README and the documentation. But my team had one minor concern, one issue. We're a team that's very much focused on the Microsoft technology stack. We've all got a sort of a focus on writing and maintaining .NET code bases, and Apollo, it's a Node.js. It's based on Node.js. That's a little different to what we're used to doing. And we were worried that that might cause a problem down the track. It could be that our lack of experience might cause us to introduce issues that, might result in, causing production issues, performance issues, or even security issues that might cause a security breach. We sat down as a team and we started to talk about how we could build their confidence in this solution. They'd identified GraphQL.net as a potential alternative to Apollo. And so they went off and did a 2-week spike to build up a prototype similar to what Sam had done, but using GraphQL.net. We came back and then we discussed the results at the end of that spike. Overall, we actually made the call to stick with Apollo. The feeling was that Apollo had a lot more features, there was more support, they had a really fast release cycle, and the community that's around Apollo is really, really quite large and active. GraphQL.net, it's more comfortable, it's .NET, but there isn't as many releases going on each year. The support isn't quite as strong. And with all the work that Sam had done, that had really made the learning curve of Apollo and Node.js really quite small and easy to climb. So that's why we felt confident sticking with Apollo.
So now that we had a decision to actually proceed with this, Sam and I sat down and started talking about the sustainability of the code. The initial implementation was quite small. There was only a couple of data sources and a few entities, but we knew we wanted this to rapidly expand. And one of the things that we talked about was how do we stop it turning into this kind of big monolithic spaghetti mess? And the suggestion that I made to Sam was that we use an organized by feature approach. Rather than having separate folders or like the whole schema in one place and then a separate folder with all the data services and separate folder with all the tests and things like that, could we instead flip that and have a folder for the people feature and a folder for the story feature, etc.? And I think, Sam, it's probably fair to say that you're pretty frustrated with me at that time.
Yeah, a little, fair to say. I just worked pretty hard putting this thing together and it was all working sweet and like ready to roll. And Rob was like, oh, let's restructure everything. And I was like, it's really going to make much difference shuffling code around. But I think Rob had a good point. You know, TypeScript is really composable by nature and I love it for that. But I'd come from probably a more naive kind of layout background where we just had like a folder for services and a folder for model, and it's just kind of layout that's going to grow and grow and grow and just get bigger as we add features. So Rob usually gives okay advice. So I thought I'd humour him and I started trying to switch over to a feature layout. And as I did it, I just became more and more convinced. I was a bit skeptical at first. GraphQL tools and GraphQL middleware packages are amazing packages that make it really easy to combine multiple schema files and files of resolvers altogether super easy. Like what Rob's showing here is we can just throw like a globbing pattern at this function from GraphQL tools, which just merges all these schema files together just naturally. And we're also making an executable schema here, taking all those type definitions from all these different files and resolvers from all the different features and just merging them all together to make one executable schema. So it's really well set up for that, and it's actually super easy to do. And I was really a convert after trying this approach.
And so to illustrate that, we've got the person feature here and the story feature here, which are the two that we've issued queries for so far. You can see both of them are actually laid out fairly similarly. Both of them have their own schema.graphql, which have their portion of the schema. And interestingly, that can include things like for a person, not only defining the person entity, but also doing things like extending entities that are defined in other features with the information that's relevant for that part of the schema. So in this case, saying, you know, the lead of a squad is actually a purple person. Both of them have their own resolver file, which basically provides the implementation of that schema from calling the backend data sources. There's a model which provides the sort of TypeScript types that those data services actually return. And then both of them, or all of them, I should say, have a separate test folder with all of the tests for us to determine whether or not that part of the model is actually working. And the way we've implemented it is exactly what Sam talked about before. There'll be .graphql files which have a GraphQL query within them that gets executed against the running GraphQL server, and then the spec file has a number of assertions against the response that comes back. Now, we not only execute these when we run it locally in the test explorer and on CI when we're building the thing, we actually also run it in the deployed environment before doing blue-green deployment swaps. So we get a lot of confidence that before we deploy new changes, the thing's actually working the way we expect. This has actually already saved our bacon quite a few times. So, Kieran, what else did we do to get this thing ready for production?
Yeah, so the next steps that we needed to do was to use infrastructure as code, in our case, ARM templates, to ensure that every environment was deployed in a repeatable and identical fashion. We extended the Azure DevOps pipeline to make sure that new versions were released to each environment, following approvals and certain conditions. And of course, as we've said, we're using the Azure App Services, so we use deployment slots for that A/B deployment, testing, and then switching. We also needed to make a few sort of minor security changes. We configured and implemented our automated web application vulnerability scanning tool, and also put in tools like npm audit and SNCC, just to keep an eye on all of the packages that are being used and alert us when there might be security issues or vulnerabilities in those packages. And the final thing that was really important was to make sure that all of the credentials and tokens and secrets that we're using in the environment are all put together and stored safely in Azure Key Vault as that sort of central credential store. Once we've done that, we're all go for launch.
Awesome. Which leads us to, how did we do that launch? Now, before we did do a launch, we needed to figure out the name of it. Now, Sam called the prototype Magnum PI, and whilst we thought that was cool, and in fact, there's still to this day an Easter egg in the Git repository with a picture of Magnum PI that originally was in the README, we didn't feel it was the right name to get this out there in a way that was kind of self-describing. And so in the end, we did call it Purple Graph. But a name's one thing. It was awesome to also have a logo. And we were really lucky because one of the consultants that wasn't even working on this just was excited about what we were doing. They pulled up PowerPoint, and in 5 minutes, they combined the GraphQL logo with the purple logo and came up with this, which we love. We think it's really cool. We also found out that you can export SVGs from PowerPoint. So you can basically get rid of your Illustrator licenses now, right? Now, the other thing as part of launching was we were really, really careful and particular about the way that we communicated it and the way that we documented it for our company. And there are a few key principles that we used in doing this. The first one was that we wanted to make sure that everyone had access to it. If you clicked a link to, say, Playground, we didn't want you to get a 403 error. We wanted it to be really seamless for everyone from the get-go. We also wanted to make sure that every time we were communicating it, we communicated the context behind it, the why. We wanted to make sure people knew why this thing existed and what problems it was solving, not that it was just some tech we thought was cool and threw together and put out there. And as part of that, we also made sure to be really clear about the strategic alignment of this to where we're heading as a business. The third thing that we did was we made sure that whenever we communicated it, there was a series of links that we would give people. And that included the source code, because we wanted people to get in there and have a look at the source code. It included links to videos of us demonstrating it so they could look at it on their own time. Links to all the user interfaces that we've shown you, like Voyager and Playground, as well as links to the Microsoft Teams environment where the core team were hanging out, because we wanted to create a bit of a community where, we would encourage people to get involved. Now, you can see here a partial screenshot of our intranet page that talks about it, which shows some of these principles. And this is a partial snippet of the Yammer announcement that Kieran did to launch this thing. One of the other things that we did as part of communicating is we showed real GraphQL queries anywhere that we could. This was very deliberate because we actually wanted to create a culture where anyone in the company, be it a technical person or someone that's slightly less technical, would be able to go in, run an ad hoc query, get some information. And we also wanted to make that really seamless. So you can see the links here, like information about a person in blue there with an underline. If you click that link, it actually pre-populates that query into Playground for you. So it's as simple as click on a link, click play, you get some data, which is really, really powerful. Now, launching it is one thing, but we needed to make sure that we followed through. We wanted this to really get out there and we wanted to encourage people to use it. And so we did a series of presentations to both really broad audiences, all the way through to I was giving one-on-one demos to executives and other people. And the way that we demonstrated it was very deliberate. We'd start off with Voyager so that we could give people an overview of the fact, okay, there's a model. I kind of understand that there's some entities that I've seen before. I kind of get what this is. Moving through into Playground, having a bunch of pre-canned queries queued up in different tabs in Playground, and starting from a really basic one and slowly layering on more complexity until we get to the point where we're showing multiple systems worth of data kind of being combined together. One of the other tricks up our sleeves when we were presenting it was we'd have a couple of tabs in Playground which had queries that you couldn't actually execute yet. But based on our vision, they're things that you would be able to execute in the future. And they were really, really powerful and inspiring demonstrations of what we would be able to do with this technology as it evolved. So we've launched this thing, people have started using it, and we've been operating it for the last few months. And there's a whole series of learnings that we've had from operating it that we wanted to share with you. The first and most important one from my perspective is this. Schema modeling is the hardest, most painful, most time-consuming thing in the whole world, but it's also the most important. And when you really get it right, it really helps you. And there's two key learnings to do with this. One of them is the mindset that you take whilst schema modeling is really important. And as developers, for years and years and years, we've been drilled to follow Yagni, right? Schema modeling mindset is basically the opposite of Yagni. So you have to just throw away years of conditioning. And instead, you actually have to think about the future, because the whole point of creating these models is we don't want to create breaking changes. So we have to think about how is this possibly going to be used in the future? Now, that doesn't mean that you implement everything and gold plate it, but it does mean that, for instance, we had one example where there was a field that right now is a single string field. But we know that that concept is probably going to grow in our business in the future. So instead, we modeled it as an object with a single string field within it. And in the future, that gives us the optionality of adding more fields and extending that type. Another key part of this is to use that domain-driven design, bounded context type of mindset. So we want to make sure that when we're modeling, we're using the language that the business uses. We had a great example where there was a particular field that the IT teams would call something. They would call it a vertical, but the rest of the business would actually call it a portfolio. But vertical is what it was in the underlying system. And so examples like that, you need to really kind of pay attention to and actually use the right language that the business is using. Now, the second part of this is the fact that schema ownership and the kind of discussion and decision that goes into creating a schema is really, really important. We need to make sure that when we're adding to a schema or adding a new schema or whatever it might be, we identify the clear owner of that schema so they can be involved in that decision. And we also need to make sure that to make for a productive discussion, rather than having lots of little discussions that asynchronously kind of build over a long period of time, we get together figuratively in a room, the owner of the schema, the developers making the change, and all of the subject matter experts that understand the business processes and data of that part of the business. The other thing that we learned was that rather than having lots of back and forth conversations in a chat window with little snippets of SDL, it was much, much more effective to have a pull request with the SDL change so that you could have contextual line by line conversations about that change in the schema. Kieran, what can you tell us about inner sourcing?
So one of the things I really wanted to do was encourage everybody in Telstra Purple not just to get involved in Graph from a consumption point of view and using the data, but also being involved in building the schema and putting in fixes and things like that, and also introducing more different types of data. Rob and I had sort of discussed different potential approaches for this and other applications and systems that I was, my team was involved in. And I really felt that an inner source approach could work really well for us. Inner source is where you basically go and use open source software development techniques and practices to establish that open source culture, but within your organization. With this My team, the DevSecOps team, would take the role of maintainers for the project, and then the rest of Telstra Purple would be contributors. Maintainers and contributors on open source projects work together to deliver new features and resolve issues. And this is what we wanted with Purple Graph. Quality assurance is maintained because contributors raise those pull requests. The maintainers do the reviews before approving them to be merged into the main branch. And what's a great example of how this inner source works in practice? Well, these are the samples of how users can consume the GraphQL data. And most of these samples were submitted by people outside of that core Purple Graph team. And that's really great to see that people were really excited about doing this and wanted to go off and create an example of how to consume GraphQL using, say, PowerShell or Power Automate.
So one of the other key learnings that we had was we've been really, really careful about how we want this to evolve from an architectural perspective. As I've said, we know that it's going to grow. We're going to add lots and lots more things, and we just don't want it to turn into this spaghetti mess. One of the things that we've done to address that is we've been really, really clear to articulate that Purple Graph does one thing and it does it well. It exposes a model with authorization and telemetry. It's a secure innovation boundary. And because of that, we've got this rule. We don't add complex logic. We just add translation. So be it a database or a REST API or blob storage or whatever it might be, we just want really simple code that takes the data, translates it into the model, and that's it. If there's anything else, we would pull it out into a separate API. We also want to make sure that we don't expose details from our underlying systems because we want to be exposing a model that describes the business. We don't want to prematurely optimize performance. And as I showed before, we've actually got a lot of great data so that Kieran's team can actually optimize based on what's really happening. They can look at a particular query and the underlying third-party calls and see which ones are the ones that actually need to be tweaked. And the other thing is that we have this preference in place for user-attended calls where possible over unattended calls. And that's mainly a security thing. If a user request is coming in, we know that Azure AD has done multi-factor authentication on them, whereas a system just has a client credential. Now, we've got in place some security guardrails to protect those client credentials, and we've also put some stuff in Purple Graph to limit the amount of data that those client credentials have access to the bare minimum. The last thing that we've had a lot of learnings on from operating this is around the cultural evolution that Purple Graph is helping us to drive. I've already given you the example of how it helps us by people answering business questions by sending queries to each other. But we've also even seen things like executives running ad hoc GraphQL queries to answer their business questions. One of those executives said to me at the very beginning, I don't believe that non-technical people are going to take up this language. You're going to have to come up with another UI. But they've since taken that back, and they now kind of share my vision of that, and they've seen examples of it happening. The really cool thing is this is driving a cultural change towards ad hoc empowered self-service access to our data, rather than waiting for more expensive or time-consuming things that might mean someone just doesn't bother asking certain business questions. And the fact that our people now have access to this data means that they're coming up with all kinds of ideas about how to use it. Now, I've got heaps of crazy ideas about what we can do with Purple Graph, but the thing that excites me the most is the fact that now we've empowered 2,000 people to come up with ideas and actually to be able to do something about it because they can just go in there and access it. And even more than that, the fact that GraphQL enables us to connect data from multiple data sources and combine them together creates for really powerful and inspirational things that simply weren't possible before. And that just adds to the excitement. So we've taken you through our journey now, and let's do a quick recap. We talked about the business context that we had, the problems we were seeing in our business that we wanted to solve. We then talked about how we took an idea of solving those problems using the secure innovation boundary and how we pitched that using consistent, persistent, and topical communication to the right people. We then talked about how we created an amazing prototype that balanced consumer experience with developer experience with the operational the ability to operate it. And that really sold it and helped make it an easy decision to run ahead with it and productionized it. We talked through how we launched it and the deliberate and careful ways that we communicated it and followed through on that. And we've taken you through some of the learnings that we've had in operating it over the last few months, ranging from the importance of the schema modeling mindset, identifying schema ownership and having productive schema modeling discussions, the impact and success that we've had from using an inner sourcing approach, our careful architectural evolution, and the really exciting cultural evolution that this is helping us to drive. Now we get the exciting bit of giving you some free stuff. So Microsoft have given 4 sort of free swag packs to give away per speaker. But the fun thing is, because we've got 3 speakers, they gave us 12 codes. So if you go to aka.ms/Azure Developer Swag, those 3 codes at the bottom there, feel free to take a photo. The first 4 people to get in with each of those gets a free pack. It might look something like this picture, or it might be slightly different. This is an example of a previous one that they had. So yay, free stuff, like any good conference. And we are really keen to sort of take any questions that you have. Now, the QR code on the top right there links off to a GitHub repository that later on today we'll put the slides up, but also has a whole bunch of links to sort of further information. Thank you. Any questions?
Hi guys, thanks for your talk. A question on how do you see this fits in with the debate around microservices owning their own data, and whether this could be an alternative or a part of the solution?
Yeah, it's a good question. The way I see it, what we're using this for is as an aggregation. So all of the sources that we're talking to could be microservices that would own their own data. And this is kind of just aggregating them out. As an example, the story feature that I showed before, I've actually created a REST API that's explicit in that Story Hub backend system that's explicitly designed to expose that data, which you could consider to be a microservice, externally. So there's things like approval tests to make sure we don't break it and all of that sort of thing. And so we can do similar things for any of the other systems that we want to. So I think they kind of go hand in hand. I don't think it's an either or thing. I don't know if you'd add to that, Sam.
Yeah, pretty much. Like, I see microservices more servicing systems, and this GraphQL API over the top, it's more consumer oriented or user interface oriented. Like things like big GraphQL API examples, like the GitHub API. They're really for people to innovate on and build systems on. Whereas, yeah, I guess microservices are more tied around like inter-system communication and just a bounded domain of data.
Hi, I just had a question about caching, because I'm guessing that you're querying up and down the graph all the time. Did you guys have any kind of interesting problems that you had to solve around caching? Because you don't want to call the same microservice two times for the exact same data, or as it's going up and down the graph.
Yeah, so there's a couple of things. The first is a library called Data Loader, which is a very commonly used package, which is pretty much essential when you build GraphQL. So Data Loader supports deduplicating and batching calls to downstream services. So that could be a downstream database, or it could be a downstream microservice. So what you get with a graph, as it resolves, it kind of like fans out from the top and spreads out. So you can end up with like lots and lots and lots of calls going out. So Data Loader first lets you funnel those down into a smaller number of calls to those downstream services. The second part of it is Apollo Service supports caching really well. I think, as I briefly explained, you can just configure cache control directives like writing the schema, and you just plug in a cache provider. So that'll give you response caching on the server side, and it will also generate HTTP response headers for clients to use. So if you're using a client that respects those HTTP response headers, the client will also be able to cache as well. So if you're using something like Apollo client, that will just work straight out of the box.
Awesome, thanks.
Cool.
Awesome. All right. Well, feel free to ask any in the Slack channel as well. We'll jump in there and see if there's anything in there as well. But look, it's been a pleasure being able to talk to you today, and thanks everyone for joining us.
Thanks, everyone.